get started now. Welcome and thank you for taking time out of your day to learn more about Orbitform, the company, and the 6 unique metal forming processes they have under one roof in Jackson, Michigan. My name is Cam Bonner and I'm with Schneider Company. We've been working with Orbitform as technical sales agents in the state of Michigan since about 1995. And we're proud to be hosting this webinar today. So 6 unique metal forming processes from one company is quite remarkable. Today in this webinar, we want to introduce you to each of them with a brief review and a video segment. The hope is if you see a process that interests you, you will let us know and we can schedule a more in-depth discussion into any one of them because there's lots to know about each of them. In this webinar, we'll spend about 5 minutes on each of the 6 processes, and then we have an 8-minute walk-around video segment of the entire Orbitform facility. At that point, we'll open it up for questions at the end. But throughout the webinar today, if you want to type in your questions into the chat box, we'll recognize them and talk about them more at the end of the presentation. So in a couple minutes, I'll turn the webinar over to Sean Cumming and the team over at Orbitform. But before I do, I wanted to take a couple of minutes to tell you a little bit more about what we do here at Schneider Company. We're a 95-year-old company, originally located in Lansing. About 6 years ago, we moved to Brighton, Michigan. We're affiliated with 10 partner companies. All of them are global brands and offer some of the most advanced technology products in their specific areas. We group these companies into 3 primary categories. Assembly process products, where we have riveting and metal forming, precision assembly presses, and screw driving and threaded fastening equipment. Testing and inspection products is the next category. We have eddy current and NDT testing, precision dimensional gauging, and process sensors and process monitoring equipment. Finally, the automation and robotics products category, we have robots, grippers and automation components, flex feeders, and pallet and part conveying equipment. Feel free to visit our website and learn more about us and these companies. Each of them have a page on our website, and on that page there are links to get directly to their sites if you want more information from them as well. Another thing that's worth mentioning, we're very involved in hands-on product and technology demonstrations here at Schneider. It's kind of a manufacturer's products version of the Apple Store here. We have about $700,000 worth of latest engineering technology products in our demo showroom and lab, and we love to have visitors. So if you ever find yourself in Brighton, give us a call and be sure to stop in and visit us. Additionally, every month here at the Tech Center, we host at least one technical event. These events can be seminars or webinars like we're doing today. They can be hands-on robot programming classes. We do that a couple times a year. Also, product focus open houses. We have one of those coming up in a few weeks. And finally, demo road trips where we'll actually take demo gear out of here and bring it to your facility and put on presentations and demonstrations or lunch and learns. So these are all things that we do here. Every month we have at least one event going on. For our up and coming events, you can go to our website events page and see what we've got planned for the near future. So that's it for Schneider Company. Now what I'd like to do is turn the webinar over to Sean Cumming and the team over at Orbitform for them to get started with their content. So Sean?
Thanks, Cam. I'm Sean Cumming, Regional Sales Manager with Orbitform, Jackson, Michigan. Today we're going to touch on several of our core processes, including orbital forming and fastening, radial riveting, impact riveting, roller forming, and hot upset riveting. Orbitform manufactures full turnkey automated systems and standard equipment for permanent part assembly. So if you're joining two parts together, you're using a rivet, a fastener, joining two pieces of metal or even plastic together, our processes are used to permanently fasten and form products together. If you need something that's field serviceable and using a threaded fastener, that may not be a process for us, but if you're looking to permanently form things together, maybe you're using a threaded fastener now and you're looking for an alternate process, maybe you're using welding now and looking for an alternate process, those are all things that we can help you out with. We have an applications lab that we'll go through and walk through later on that does a lot of that type of pre-evaluation work. So if you're in the early stages of product development, you're designing something new and you're looking for a manufacturing and assembly process, please contact us. We can help you, early on in those stages. If you're manufacturing something now and maybe it's a bottleneck operation and you're looking to make a change, maybe there's something that we can help you out with in that regard. So like I say, today we're going to touch on a lot of our processes. We're going to walk you through all those details. At the end, we'll do a quick walkthrough, quick plant tour, and then we'll open up some time for questions and answers. If you can't stick around to the end and you want to email me directly, you can email me at scumming@orbitform.com, and I'll get back with you as soon as I can. Welcome to Orbitform. Or applications that don't require free moving at all, like a sprinkler assembly that is just forming the brass tenon to retain the deflector, or an automotive dampener that requires the forming of the end of this tube. Here's a special peen that was developed for that. The process works by setting the peen tool at a 6-degree or a 4-degree angle. So we're showing an example of a servo-driven power head here. Behind me we show a long stroke power head. This is a 6-inch stroke power head. Most of the servo models have 4 inches of travel. Most of our pneumatic, the stroke varies with model, but on upwards of 2.5 inches of usable adjustable stroke. So for larger riveting applications, we might consider our 1000 power head. This is a hydraulic unit. We've got 2 hydraulic models, a 1000 and a 1500. This is 18,000 pounds of hydraulic forming capacity. The 1500 has 38,000 pounds of forming force available. So in general terms, the 1000 is suitable for a 1-inch diameter mild steel rivet, solid rivet. And this particular arrangement is on a pedestal. So if you had longer tubular parts or just longer parts in general, you've got more room here to be able to adjust the lower tool. As with all of our power heads, these can be mounted and integrated into fully automated systems, just with the mounting plate here to tie it back to a column. This configuration we're showing here just has our standard touchscreen, a work light, and it's a hydraulic power head, but it's still turning the spindle with an electric motor. And the tool again rotates 1200 RPM to apply that downward force on the part. All right, now we'll look at a quick video to show you the process in action. Here are 4 different power head sizes: the 125, the 240, the 310, and the 500. They're all pneumatic in this particular case. They are electric motor driven, and we're showing different tooling configurations. We're showing radial, orbital, multi-point, and multi-spindle. And it just gives you an idea of some of the different configurations. Every configuration is application specific. If you're looking to form more than one rivet at a time, if the rivets are very close together, we'd use a multi-point. If the rivets are further apart, we'd use a multi-spindle, or if you have several rivets together in one grouping, we could use a multi-spindle arrangement. The radial process is very good for very small parts, delicate materials, things that have really long tenon stick-outs. There's different processes or different applications that are suited well to radial. That's one of the things that we like to use our lab for, is to really develop the process and look and see which, is it orbital, is it radial, is it multi-point, multi-spindle, and give you that feedback out of our lab. Talking about the radial process, here's an example of a benchtop B125 with a radial spindle. Different applications that might be suitable for radial riveting are very small pivot points, tiny rivets, and surgical scissors. Like I say, very small components. One of the things to note is that our standard Powerhead product line allows you to interchange between radial and orbital. So if something were to change with the product in the field and you did need to change the process, that something as simple as changing the spindle cartridge and the radial head. The way the radial process works is there's a series of planetary gears inside this head that drives the peen tool through what we call a spirograph type pattern. So with orbital, the forming peen is spinning at 1200 RPM. In this case, this tooling head is not moving at all. It's the peen itself that's inside here, the forming tool, that is moving. It's driven through that type of process. It's still being applied, the pressure is still being applied with the pneumatic power head. Could be servo as well. And radial is a process that we apply through all of our power heads now up to the 750. It's identified by the blue cone. Again, this does not rotate like the orbital process does. A pressure pad can still be integrated around the exterior of this, and so we can apply a clamp load to hold all the parts together while it's in the fixture while the rivet's being formed. Okay, let's look at a video and show some examples of this process. Riveting or impact riveting is a process of auto-feeding rivets and setting them with a lower tool. So basically the operator stands here, loads the part over top of a spring-loaded roll set pin, activates the machine with a foot switch or palm buttons, and the rivet is fed down the track and immediately gets set through the part and curled over by the lower roll set. Semi-tubular rivets and solid rivets are traditionally what's used through this equipment to produce parts of all different types of applications. In this particular case, circuit breaker with a semi-tubular rivet through a layer of plastic material. We have a section of a bed frame, so this is where the headboard bracket is with your legs set. A couple of rivets, semi-tubular in this case, and one solid in the other case. So you got a couple of both here. This is a collapsible tent or cot mechanism with different types of rivets. So lots of these are semi-tubulars. You'll see that in some cases the joint can swivel and move, and in some cases it's designed not to. So they're using 2 rivets here to hold that particular component together tightly. Another application for impact riveting might be fan blades, HVAC, lots of semi-tubular rivets to hold fan blades to the center hub or spider. And in lots of cases, impact riveting is used for applications that are not designed to swivel, hinge, or move. The joint is supposed to be rigid, have some compressive loading to it, where the rivet gets swelled, fills the hole of the joint, and then creates a nice tight joint. The equipment to install that type of rivet is either a pedestal or this is a benchtop type arrangement. It can be flywheel driven, so an electromechanical type mechanism where an electric motor drives a flywheel. We also have these units available in pneumatic or hydropneumatic. It really depends upon the application, the rivet size, type, semi-tubular, solid, and material. The impact riveting process works by auto-feeding a rivet down a track through either a rotary or a vibratory feeder. Every time the machine cycles, the rotary feeder turns, singulates a rivet into the track. The rivet travels down the track and gets trapped by a selector. So every time the machine cycles, one index of the machine triggers the selector to operate, and then one rivet drops into the jaw at a time. So when the part is loaded over the spring-loaded locating pin, the rivet is already ready to go in the jaw. Once the machine is activated with a foot pedal or a palm button, the jaw travels down, carrying the rivet, and the driver, which is the upper tool, gets pushed down, pushes the rivet out of the jaw. It's intercepted by the lower spring-loaded roll set or anvil pin, and that traps it to travel through the part. And once it hits its full stroke, the rivet starts to curl based on the form geometry of the lower tool. That's how the sequence works. For setting multiple rivets at the same time, we have a couple of options. Our pneumatic riveting heads, which are shaped like a wedge style so you can get multiple riveting heads really close together, or our fixed center impact riveters, where this particular unit is an electromechanical flywheel driven machine with one spindle with 2 drivers and 2 roll sets. So we're setting 2 rivets at the same time. There's a couple of different reasons for going pneumatic or the fixed center, depending upon how far the rivets are spaced apart. If they're less than 1.5 inches of center line distance apart, the single spindle, dual tooled fixed center machine is a great option for it. If you have rivets that are further than 1.5 inches apart, then multiple pneumatic wedge head machines might be the better approach. We can also mount these to a slide, so you can achieve an adjustable center distance. And these can be mounted also at different angles. If the part, had a rivet on a particular angle, these can be mounted up to a 20-degree angle to be able to achieve that. The safety for both of these types of machines, as with the single spindle, the Milford Standard safety probe includes a wire. It's a point of contact device. So this travels the entire stroke to make sure that the operator's fingers aren't in the way before the machine activates. So we have a couple of different styles of safety, or this is for a foot pedal type activation where the operator's hands are free, but we could also have fixturing here where the part is actually loaded into a fixture. The operator can let go of it, activate the machine with 2-hand control, and then their hands are tied to the safety buttons. So a couple of different options there, as well as with these guys. If they're integrated into a machine, you might envision a large base here with multiple heads on it, with a fixture that the part sets into, maybe a set of light curtains. The operator can stand back after they have loaded the parts up, hit the machine, hit the button, and then all the riveters are cycled at the same time. The pneumatic riveters operate with a single pneumatic cylinder inside, and there's still a set of toggle arms inside to be able to create the actual pressure, the downward force. All the machines are sized based on the rivet diameter, material, and type, whether they're semi-tubular or solid. We've got a full range of equipment to suit all sorts of different diameters, material types, and types of rivets. Let's check out the video of the process. So let's talk about roller forming. From time to time I hear customers say that we don't do any riveting. Well, not every part includes a rivet or a fastener. Some parts just have cylindrical tubes or features that just need to be formed over. which is why we developed this roller forming process. We have two different types. One, static roller forming, where the rollers are on a fixed dimension, and we turn the rollers using our power head, and we advance it into the part, and essentially you're creating a formed lip around the end of the part to hold the components together. So here are a couple of examples of static roller forming parts where you have straight on access to the formed lip with the rollers. Again, turning a fixed dimension of rollers around at around 400 RPM, and then crimping or forming the lip. The other roller forming process is called articulating roller forming, this is an example of an articulating head, actually our smallest unit. And again, the rollers are turned using the power head and advanced and retract using the power head. And the rollers themselves are brought in and out on the horizontal, either pneumatic or with a mechanism that allows them to draw in. And a couple of examples of articulating roller forming parts. Here's one it's a tubular part, but it has, you'll see this plastic component here, this connector causes an obstruction or not a straight on shot to this lip. So the rollers are spinning, they're coming around over top, and then they come in and form the lip, retract, and then get out of the way. Here's another part where we're forming this groove here, so the rollers come in, form, and retract. Here's another type of a connector where we're joining metal to plastic and forming this groove around the 360 degrees to form the two parts nice and tight together. They don't rotate, they're held very tight together. Here's a cross section of another piece where we're coming in, forming this cap down. The cap's pressed in, there's a little O-ring in there to create a sealed interface, and then we're forming the cap on. So an advantage of articulating roller forming over crimping is that we get 360 degrees of retention. It creates a nice joint, and then if you do need sealing characteristics, typically that's designed into the joint with an O-ring or gasket or other feature. I touched a little bit on this process. This machine configure here is in our lab. It gives us some flexibility, so it's just showing a simple fixture to allow for adjustment in the diameter of the parts. Two-hand control, standard. This is an offset motor drive, and what you'll see up top here, the reason for the offset motor drive is we have a through spindle pressure pad. We talked a little bit about pressure pads previously and what they're used for to clamp parts into the fixture. Through the center of this power head, there's a rod that doesn't turn, it just advances and retracts, and the end of that rod is threaded, and we can put a feature on there to help apply the clamp load. So once the part's in the fixture, that through spindle pressure pad comes down, applies a clamp load on the part with the cylinder up here, holds everything nice and tight together in the fixture while the rollers come and form. And so that through spindle pressure pad acts independently of the roller head turning. Let's check out the video of the process. Here we're showing our flaring and flattening process as it applies to a bushing. So this is a Norglide bushing that needs to be flared out 45 degrees before it gets flattened. We have tooling adapted to our 750 pneumatic power head, and it has a pneumatic actuator to allow the tooling to rotate after it's come in and flared the bushing. Tooling rotates, activates again, and then it's flattened. So at the final form is a nice flat bushing. And what this is used for is in a lot of pivot points that require a specific effort or torque after a rivet is joined, the two components together. This bushing provides that type of consistent feel and torque into the design of the part. We're just showing you here that it's another process that can be attached to our pneumatic power heads. Let's check out the video. This is our hot upset riveting process. It's our only hot forming process, so we use a weld controller and our power head as the forging head or weld cylinder to apply the pressure to the part prior to and during the forming operation. This process allows for exceptional hole fill. So if you had a square part or stamping and you were putting a round rivet or tenon through that square hole and you wanted to get ultimate hole fill, this process is very good for it. It's also good for hardened materials and rivets that don't cold form very well. A couple of other examples of applications used or that hot upset is used with are striker wires. So forming the wire, we can form two different striker wires but with a cascading method, coming down, forming one, shuttling the part over, forming the other, or using two different tools. This is a truck brake assembly where you've got three different rivets that are hard rivets so that they don't cold form very well, and they need that exceptional hole fill. So these were formed with hot upset. And we have this logging or mining chain example where we are heating this tenon up and forming it. It took about 30 seconds or so to form this because it's so large, but a typical hot upset cycle time might be 3 to 4 seconds, plus your part moves. This particular machine is showing a pressure pad, so once the part's loaded in, the power head advances down, brings the upper electrode into the part, so everything is touching. The pressure pad is clamping the part. Once the machine is activated, current flows through from the upper to lower electrode to complete the circuit. Once the material gets hot enough or malleable enough to form under pressure, then the pneumatic pressure from the power head or the cylinder pushes the material together and causes that nice hole fill, that nice joint. The tooling is then cooled, so you're extracting the heat, and then everything draws everything together nicely. Let's cut to the video. So let's take a tour around. Now that we've talked about several of our processes, the first of which was the impact riveting. This is our impact riveting build area. We're currently producing a semi-automated machine for a customer building garage doors where we are incorporating multi riveting heads here. Those are all pneumatic riveters there in a row. One has an adjustable center, and we've got conveyors helping to transfer the panels into position. We're going to take a quick walk down to our paint booth and machine shop before we head all the way around, and then we'll cover the rest of the assembly area on the way back. I'll take a quick stop here. From time to time, we do buy equipment back from customers and then refurbish them, and we can sell them as an FRM or factory remanufactured machine. So we do have some inventoried carcasses ready to be refurbished and rebuilt for customers. Over here on my right is our machine shop. So we'll head down through there. So currently we manufacture 95% of our components in-house with CNCs and with other manual operations. We also have a quality inspection lab to make sure that all of the components that go into our equipment, as well as service parts and tooling, meet the quality expectations of our customers. And we inventory a lot of our components, so they are available and in stock. Components that are very specific to a machine or an application, we provide a recommended service parts list with the equipment, with the lead times associated with those so that customers can plan accordingly. But a majority of our standard items are here held in stock. And here we have a variety of our standard pneumatic power heads available in stock. And down on the end, we show our standard bench machines with a standard controls configuration. So you'll see the product line here with a 125, our smallest unit, up to our 840, 845, the largest pneumatic power heads on the market. 12,500 pounds of forming force at 100 PSI on those guys. And then we have a hydraulic head. This is a 1000. The 1015 means that it's outfitted with a load cell and an LVDT. Here's a variety of standard bench machines with our standard controls package. They're all two-hand control, touchscreen, automation, direct PLC, and touchscreen. This happens to be a 750 on our standard T-slot, adjustable height column on a standard fabricated base that's manufactured here in-house. A couple of copies of that guy, followed by 3 of our 500 series. These are 1/2-inch diameter mild steel riveters, same configuration as the 750s. Then we have our 240 and our 310 here on the end. All of the bases with fork tubes on casters. Guarding for our impact riveting equipment, which I'll touch on in a minute from our fabrication department. This is our working applications lab. So customers who are looking to have parts produced or samples created for them to evaluate, whether they're looking for fastener recommendation, rivet stick out, formability of material, or even a small production run. That's all something that we can help and take care of here through our solutions lab. There's 3 full-time employees that work in the lab, and there's over 20 pieces of equipment that's all in variety of configurations, ready to be used to produce parts for customers. And then we also hold several machines here that we take to our trade show. Here's our fabrication department. We manufacture our bases, columns, machine guarding, all in-house. We have a Trump True Laser 2030 fiber laser here. And over here we have our Powerhead build area. A couple of things to note. This is where we build all of our standard Powerheads. Each Powerhead gets put through rigorous testing prior to shipment. We either run it through 1,000 cycles or 8 or 4 hours of cycle testing, depending on the model and configuration, to make sure everything is rock solid before it ships. Here we have a couple of used machines. So some customers will send back older equipment to have us refurbish them. These are being remanufactured in-house. And this is the rest of our assembly and machine build area. So we're building equipment here that's eventually going to leave and end up at our customers' facilities. All this equipment gets run off, and we welcome customers to visit us for training. If that can't be arranged because of their location, we can often do video conferences. So we'll be in front of the machine running it off with the customer at the other end at their location, so that we give them the feedback, or they can give us feedback prior to the machine running, being shipped. So they do that buy-off process, online or in person. And something I didn't touch on earlier, but process monitoring. So depending upon the type of equipment, whether it's orbital forming, radial riveting, impact riveting, roller forming, or hot upset, there is a level of process monitoring or process control that can be applied to these machines. So if we are building the full system with controls, and you're looking to have, let's say, poker yoke fixtures to make sure all the parts are present prior to forming. You want to know what happened during the forming cycle. You want to measure or monitor parts prior to forming so that you know that what you've put into the machine is good prior to activating the machine. All those sorts of things can be addressed, during the process here. So we can cover a little bit more if you've got questions in the following section.